Hello everyone and welcome back to our channel. Today we're diving into the sort function in PySpark, a simple yet powerful tool that helps you sort your data frames with ease. Sorting is an essential part of data analysis as it helps organize your data, making it more readable and insightful. Whether you want to rank products, handle missing values, or organize sales data, the sort function makes it effortless. In this video, we'll go through practical examples that will show you how to use sort effectively and make your data analysis smoother. So let's get started. Introduction to the sort function. The sort function in PySpark is used to sort a data frame based on one or more columns, helping you organize and present your data in a structured manner. It allows you to sort data in either ascending or descending order, making it easy to see trends, rankings, or important values at a glance. The sort function is essentially the same as the order by function, and both can be used interchangeably with only slight differences in syntax. Whether you need to sort by a single column or multiple columns, sort is a flexible and powerful tool for arranging your data. Sorting is an essential step in data analysis as it makes data more readable and easier to work with. For example, you might want to sort sales records to identify the highest sales or sort by dates to view information in chronological order. Using the sort function ensures that your data frame is well organized, allowing for more effective analysis and helping you draw meaningful insights. Whether you are preparing data for reporting, visualizing trends, or simplifying data exploration, sort makes it easier to achieve a clear and structured view of your dataset. Basic syntax. The basic syntax for using the sort function in PySpark is dataframe.sort calls, ascending true. This function sorts rows based on one or more columns. The calls parameter specifies which columns to sort by, and ascending determines the sort order set to true for ascending, default, or false for descending. You can pass a list to ascending to control the order for multiple columns. Using sort helps organize data logically, making it easier to interpret and analyze. You can quickly arrange data to highlight trends, improve readability, or prepare for further analysis, ensuring a more structured view of your data frame. Why use sort function? The sort function in PySpark is used to organize data for easy analysis or presentation. It is especially useful when ranking or prioritizing information, helping to identify key patterns or trends. Whether you need to sort sales, dates, or other columns, using sort improves readability and facilitates decision making. While sort and order by are similar, sort is often preferred for straightforward sorting with fewer columns. It provides a simple way to structure your data frame, enhancing visualizations and making analysis more effective. Practical examples. 1. Sorting data in ascending order. In this example, we have a PySpark data frame DF that contains sales data for different items. The data frame consists of two columns, item and sales. The item column represents different products, while the sales column holds the corresponding sales values for each item. Our goal is to sort the data based on the sales column in ascending order. This means that the lowest sales value will be displayed first, followed by higher values. To achieve this, we use the sort function, specifying sales as the column to sort by and setting the ascending parameter to true. By sorting in ascending order, we arrange the data starting from the smallest sales value, making it easy to understand how sales progress from lower to higher. This type of sorting is especially useful when you want to see the least performing items first or identify the range of sales values. Using the sort function in this way helps to provide a clear view of the data, making it more readable and enabling you to draw meaningful insights. By sorting sales in ascending order, it becomes easier to compare items and evaluate their performance relative to one another. After sorting, we use the dot show method to display the organized data frame. Overall, this example demonstrates how to use the sort function in PySpark to sort rows based on a specific column in ascending order. Sorting helps to structure the data in a logical way, making analysis and comparison more straightforward and facilitating better decision making. 2. Sorting data in descending order. In this example, we have a PySpark data frame DF containing sales data for different items. The data frame has two columns, item and sales. The item column represents the names of various products, and the sales column contains their respective sales values. Our goal is to sort the data based on the sales column in descending order, which means that the highest sales value will be displayed first, followed by smaller values. To accomplish this, we use the sort function, specifying sales as the column to sort by and setting the ascending parameter to false. This way, the sales data is arranged from the highest to the lowest, allowing us to easily identify the best performing products at a glance. Sorting in descending order is particularly useful when you want to prioritize items with the highest values, such as the top selling products or highest performing metrics. Using the sort function in descending order helps to quickly determine which items are contributing the most to overall sales and provides a clear ranking of products based on their performance. This type of sorting is especially effective for generating reports, understanding the distribution of values, and making data driven decisions about where to focus your efforts. The dot show method is used to display the sorted data frame, making it easy to review the organized results. Overall, this example demonstrates how to use the sort function in PySpark to sort data by a specific column in descending order, helping you effectively analyze and rank your data to gain insights into top performers and trends. 3. Sorting by multiple columns. In this example, we are working with a PySpark data frame DF that contains sales data for various items. The data frame consists of two columns, item and sales. The item column represents the product names, while the sales column shows their respective sales values. Our goal is to sort the data first by item and then by sales, both in ascending order. To achieve this, we use the sort function, specifying item and sales as the columns to sort by. First, the data is sorted alphabetically by the item column. Within each item, the sales values are further sorted in ascending order. This means that if there are multiple entries for the same product, the sales records for that product will be arranged from the lowest to the highest sales value. Sorting in this way is useful when you want to group the data logically by product and also see how sales vary for each product. It provides a structured view, making it easier to analyze sales performance within each item category. For example, sorting by item helps keep all similar products together, and sorting by sales within each item allows you to see the sales progression for each product. The dot show method is then used to display the sorted data frame, presenting a well organized view of the items and their sales values. This approach makes it easier to understand the performance of individual products, analyze patterns, and derive meaningful insights from the data. Overall, this example demonstrates how to use the sort function in PySpark to sort rows by multiple columns, providing a detailed and organized view of the data. Sorting by both item and sales makes the data more readable, allowing for effective analysis of trends within each product category. 4. Sorting by multiple columns with mixed orders. In this example, we are working with a PySpark data frame DF that contains sales data for different items. The data frame consists of two columns, item and sales. The item column represents various products, while the sales column contains their respective sales values. Our objective here is to sort the data first by item in ascending order and then by sales in descending order. To achieve this, we use the sort function, specifying both item and sales as the columns to sort by. We also provide the ascending parameter as true false, which means that the item column will be sorted in ascending order while the sales column will be sorted in descending order. This means that all items are grouped together alphabetically, and within each group, the sales values are ordered from the highest to the lowest. Sorting in this manner is particularly useful when you want to see all records for each product together while still prioritizing higher sales values within each product group. For example, you can quickly identify the best sales records for each product, allowing for a deeper understanding of which items are performing well. It provides a comprehensive way to evaluate the top sales for each item and to get an overview of performance at both the product and sales level. The dot show method is used to display the organized data frame, which now has an orderly structure where items are grouped and their sales values are presented in descending order. This structure makes it easier to analyze performance trends and determine which items are consistently achieving higher sales. Overall, this example demonstrates how to use the sort function in PySpark to sort rows by multiple columns with different sort orders. Sorting by item in ascending order and sales in descending order helps maintain a logical structure for the products while prioritizing the top performing sales within each group, facilitating each data analysis and insights. 5. Sorting with expressions. In this example, we are working with the PySpark data frame df containf containing sales data for different items. The data frame consists of two columns, item and sales. The item column represents various products, while the sales column contains their respective sales values. Our objective is to sort the data based on sales values after adding 10% to each value, allowing us to see how sales would look after a hypothetical increase. To achieve this, we use the sort function along with the XPR function. The XPR function allows us to create an expression that modifies the sales values by multiplying them by 1.1. This calculation adds 10% to each sales value, effectively increasing the values by a fixed percentage. The sort function is then used to order the rows based on these adjusted values. Sorting data after modifying it in this way is particularly useful for analyzing the impact of changes in sales, such as forecasting or projecting growth. It gives you an understanding of how the data might look after applying certain transformations, such as a price adjustment or a hypothetical increase in performance. By sorting based on adjusted sales, you can easily identify the products that would benefit most from the increase or better understand how the changes affect overall rankings. Finally, we use the dot show method to display the sorted data frame, which now lists the items based on their adjusted sales values. This approach helps to provide insights into different scenarios, such as understanding potential improvements in sales, and allows for more informed decision making when considering changes to sales strategies. Overall, this example demonstrates how to use the sort function along with an expression to sort rows based on modified values. It's a powerful way to understand the impact of different scenarios on your data, making analysis more insightful and allowing you to make informed strategic decisions. 6. Handling null values in sorting. In this example, we are working with the PySpark data frame df underscore with underscore nulls that contain sales data for different items. The data frame consists of two columns, item and sales. The item column represents various product names and the sales column contains the respective sales values. Importantly, some of the sales values are null, which means that the data is missing or unavailable. Our goal is to sort the data based on the sales column while specifying whether the null values should be placed first or last. In the first scenario, we use the sort function along with async underscore nulls underscore first. This means that we are sorting the sales column in ascending order, with null values appearing at the beginning of the sorted data frame. Placing null values first is helpful when you want to prioritize and easily identify the missing or incomplete data. By sorting with null values at the top, you can quickly see which records have missing information and address them accordingly before proceeding with further analysis. In the second scenario, we use AC underscore nulls underscore last to sort the sales column in ascending order, but with null values placed at the end. This is useful when you want to focus on analyzing the complete and valid sales data first, without interruption from missing values. By placing null values at the end, you can concentrate on analyzing the records with available sales data, making the data frame more readable and useful for making decisions based on complete information. Finally, we use the dot show method to display the sorted data frames, each with a different treatment for null values. Sorting the data in this way allows you to have greater control over how missing information is represented, making it easier to decide whether you want to prioritize addressing missing data or proceed with analyzing available values. Overall, this example demonstrates how to use the sort function in PySpark to control the position of null values during sorting. By using AC underscore nulls underscore first or AC underscore nulls underscore last, you can effectively manage missing data, making it easier to focus either on incomplete entries or on fully available information, depending on the requirements of your analysis. Thanks for watching. I hope this video helped you understand how to use the sort function in PySpark to organize your data easily and efficiently. Sorting is an important aspect of working with data, and mastering it can make your data analysis process much more productive. If you found this video helpful, don't forget to like it, subscribe to our channel for more PySpark tutorials, and hit the notification bell so you never miss an update. And as always, feel free to leave any questions or comments below. I'd love to hear your thoughts or help answer any questions you have. Until next time, happy coding and keep exploring data.